There are two key words you need to know. One of them is divergent. Divergent, or a divergent series, is when the series gets bigger as you go along. So for example, 2 plus 4 plus 8 plus 16 plus blah 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 blah. It's getting bigger as you go along, right? And that is pretty much going to go till infinity. The opposite is when they get smaller as each term goes on, which is known as a convergent series. So 1 plus a half plus a quarter plus an eighth and blah 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 until you also get to infinity. Now, a series is convergent if the modulus of r is less than 1. That you need to know. Okay? Convergent series gets smaller as you go along, and the proof, or to know whether or not a geometric series is actually convergent, is if the modulus of r is less than 1. Okay, sum to infinity can be written as S infinity. We looked at Sn for arithmetic series. We looked at Sn for geometric. This is also a type of Sn for geometric, except it's all the way to infinity. And lucky for you, is another formula you need to know. So, the sum to infinity formula, it's super easy. A over 1 minus r. That's it. Okay? And this works for a convergent geometric series. Okay? If you have a question involving sum to infinity, most likely it's going to be a convergent series anyway. But just make sure that it is one before you use it. Cool. Let's have a look at this question. Let's have a look at this question. For a geometric series, a plus ar squared, S3 is 9 and S infinity is 8. Okay, how can you write S3 using A's and R's? You would write A bracket 1 minus r cubed over 1 minus r, and we're going to make that equal to 9. Easy. How would you write S infinity? A over 1 minus r. You're going to make that equal to 8. Now what you have essentially is a simultaneous equation. So, can you try and solve that simultaneous for me, please? So if we make this equation 1, we make that equation 2. And let's try and get a substitute. Let's make this 8 bracket 1 minus r, and let's sub that into equation 2. So it becomes 8 bracket 1 minus r cubed all over 1 minus r equals 9. These 1 minus r's cancel out, so you're left with this, which means 1 minus r cubed is equal to 9 over 8, which means r cubed is equal to minus 1 over 8, so r is minus a half. And now sub that into equation 2, and you get a equals 12. Easy. And that's making use of the sum to infinity and the regular geometric series sum formulas. Okay, long question. I want you to try this on your own, please. Okay, for part A, we're going to label what we know. The first term is 30. The sum to infinity is 240. We want to show the common ratio 7/8. Sum to infinity, the general equation is a over 1 minus r. So that means 30 over 1 minus r is equal to 240. So 30 over 240 is equal to 1 minus r. So that means 1/8 is 1 minus r. A is 7/8. Okay, that's part A done. Part B. Find to 3 significant figures the difference between 4th and 5th terms. Okay. The 4th term, which you can write as u4, is ar cubed. The 5th term is ar to the power of 4. You know a, you know r. 37/8 to the power of 3, and then 30 times 7/8 to the power of 4. Stick both in the calculator, minus them, so you're going to do u4 minus u5. 30 times 7/8 to the power of 3 minus 30 times 7/8 to the power of 4. And you should get 2.51. Cool. Part C. Calculate the sum of the first 4 terms, giving your answer to 3 significant figures. Okay, it's a geometric series. We want S4. And our R is less than 1. 30, 1 minus 7/8 to the power of 4 over 1 minus 7/8. Nice and easy. You get 99.3 after plugging it in the calculator. Last question. The sum of the first n terms of the series is greater than 180. Okay, calculate the smallest possible value of n. Okay, so if the sum of the first n terms is greater than 180, let's try and work out what exact value of n equals 180. 30 bracket 1 minus 7/8 to the power of n over 1 minus 7/8 equals 180. And from here, it's just a matter of simplifying. So let's do 30 bracket 1 minus 7/8 to the power of n all over 1/8, because that's what it simplifies to. And now this can all simplify to 0.75. So you can take that over and times it. You can then take that over and divide it. And that will equal 0.75. Cool. Now, 7/8 to the power of n equals 0.25. That's me taking this to the right and that to the left. That way, you get rid of that negative in front of the bracket. Don't want a negative in front of the bracket, sorry. Now you can take log of both sides and use the power rule for logs to bring that n in front. You can then divide the log and when you stick that in the calculator you get 10.38. So when n equals 10.38 you get 180 exactly, which means n equals 11 because n has to be an integer. 10 would be less than 180 for the sum of. 11 would be just over 180 for the sum of. And there you go. Sum to infinity.